Hi, everyone. So tonight is going to be an introduction to entity component systems with a library that I created called EgoCS. It's an implementation of this paradigm. So just a first warning, there will be opinions in this talk. Most of them are my own. Yeah, please hold all of your tomatoes until the end. I'm going to talk about a few bread and butter paradigms and patterns that we use when we're creating specifically gameplay code, so implementing all of our mechanics and systems and all that, not the lower level stuff, the more game designing stuff. I'm going to be talking about why I think entity component systems are really great, and but first we're going to go through some of the friction points in current ways that we develop typical gameplay code today. Okay. So this is from my experience just working on gameplay code, but I think this can apply to just programs or any sort of work in general. Our features and our game is like a big jawbreaker. Does everybody know what a jawbreaker is? It's, for those of you who don't, it's essentially just a candy that you suck on, and it's made up of layers and layers and layers of different colored sugar coating. And if you try to eat it, you will break your jaw. So the features that we add to our games are like these internal layers in this jawbreaker. It's really easy just to keep adding another layer and adding new features, because whenever you add something, you are easily building on top of and around all of your previous code. However, what I've noticed when the design changes, or so if you need to completely remove something, or just in your testing, if you have to disable something, it's really hard to do that. Often to remove or disable something, it's time consuming and errors are basically guaranteed. So how do we structure our code today? How do we keep on top of that? One of the most popular ways, of course, and most fundamental ways is state machines. I think they're fantastic until they're not. If you just Google mechanism or state machine or whatever the Unreal equivalent is called, you usually see graphs like this. They're not pretty. After 5+ states, it gets, in my opinion, it gets really messy and really hard to debug. Especially with 5 states, it gets really easy to draw a pentagram, so that's not a good sign. The other thing with state machines is in our games, especially like if you're working on a more systems-driven, data-driven game where just it's a whole bunch of systems and objects interacting with each other, you can be in more than one explicit state at any given time. So here we've got run to idle, cannon pose left, but then we could be in a pose that's not run or not run to idle. And now this is just an animation example, but even in our game, we could theoretically just be in a state that we haven't expressed yet, and then we have to account for that. One way to solve this particular type of mess is with hierarchical state machines. In my opinion, they help, but you're moving all the spaghetti from one pot into a stack of n bowls. It's much better because you only deal with one layer at a time, so you're dividing and conquering the problem. But at the end of the day, it's still spaghetti. Okay. Common pitfalls that I've seen in object-oriented programming, and I'm talking about the OO that you see in C++, Java, and C#, which hopefully a lot of people here are familiar with if they're working with Unity. The best way I've seen OO described is that it favors immediate calcifications of nouns with verbs, or your types and your classes with methods. So here I've got dog.bark. So dogs can bark. Players can move by a given delta, etc. This calcification, this hardening of your design, in my opinion, it works really well when all the design is up front. So for a school project where all the criteria is up front there, it works great. When you're following a tutorial online about how to implement or clone a Breakout or Tetris or a certain game, all the design is up there. So with OO, it works. But then when you're working on an actual game, this literally will never happen. Your design is constantly changing, whether your design is constantly changing. The worst time to lock in your design is right at the start. And also there's an innumerable amount of interactions between the game objects in your game. So there's collision, there's crazy stuff like the Nemesis system in Shadows of Mordor. There's all these different weird and abstract ways that our game objects can interact with each other. And by calcifying, by just saying, oh, this object can bark, and maybe these 3 other methods, it's really limiting, in my opinion. Encapsulation, it aims to protect object state and provide public accessors. In theory, this is really nice. You don't want things changing, you don't want people reaching in and changing stuff from under you. However, I often find that encapsulation, at least in games, is a premature design decision. Typically because gameplay code has amazing cross-cutting concerns. Like if I'm working on a breakout clone, my designer can come up to me and say, oh, well, when the ball hits the brick, it needs to create some particle effects, and the brick needs to gets destroyed, and the score needs to go up. So already I'm dealing with so many different orthogonal and disparate parts of my game and my engine, and encapsulation will just often or not get in the way. You set everything to private, but then eventually you're going to have to resort to like private setters, public getters, just everywhere. In my opinion, it just adds friction, because any state that you hide now will have to be exposed somehow in some way later. Inheritance. Other than not using it entirely, even the Gang of Fours explicitly state composition over inheritance, but few of us listen. Thankfully, we've gotten more away from that. Even Unreal is getting more away from that, which is awesome. I found that, especially like in a lot of older games and in engine code, inheritance hierarchies are often super deep when instead they should be wide. The reason for that is the best and worst reason to use inheritance is because any changes you make higher up the hierarchy will have cascading effects further down. That's both amazing and super bad. Usually it's super bad. There's also some other stuff with inheritance, like Java and C# don't let you do this, but in C++ you can do multiple inheritance. You can run into the deadly diamond of death problem. When your design does get updated in your game, and you have to move some member variables around, or you have to move some functionality higher up, I've always found that hierarchy rearrangement is like pulling teeth. And what I noticed when working on some school projects and some professional projects now, that your base classes will become often too generic and too bloated, because you're trying to share functionality across multiple different types of objects. So the majority of them might use that functionality, but the minority of them won't. So you're still, you're still duplicating some data and some functionality that you might not need, maybe now nor ever. So it's a little bit wasteful, and it can bite you later. Polymorphism, function and method overloading is cool. I like that. There's very few cases where type and class polymorphism are nice. Like if you're just using the methods that you're overloading to define very explicit behavior on your object, that's fine. Other than that, nah. Okay. Finally, now this isn't one of the 3 pillars. Sometimes it's called the 4th pillar, abstraction. In my opinion, too much abstraction is like rose-colored glasses. Like we have this problem in front of us, you're holding it in your hand, and we think that putting on rose-tinted glasses will make this object either look prettier or go away. Hopefully it'll just go away. But then we put on one layer of abstraction and it's still not solved. So we keep adding more and more lenses and stacking our rose-colored glasses further, and we blur and tint the problem until it's solved, in air quotes. When we do stuff like this, like when we over-abstract the problem, we get over-engineered solutions to problems that really shouldn't exist in the first place. Stuff like dependency injection frameworks, inversion of control, frameworks that are trying to sidestep and work around the limitations of object-oriented programming. Now, specifically from a game programmer perspective, we're really forgetting that all we're doing is transforming data. We have some data at the start of our frame, we update it, and then the frame ends, and then we do that all again. There's an awesome talk from Mike Acton. He's the engine director at Insomniac Games. It's up on YouTube. It's titled CPBCon 2014, Mike Acton, Data-Oriented Design in C++. I'm not going to go into specifically what data-oriented design entails, but I really enjoyed that talk. I met him at GDC one year. It felt like like as I was talking to him about this, it felt like I was a new student entering the dojo and sensei kicked my ass. What I really got from that talk was, as a game programmer, gameplay programmer to be more specific, we don't need to perfectly model the world. Games are real-time interactive simulations. They're not perfect models, nor should they be. Like if I'm modeling this room around us, I don't need to make this a table. I don't need to make this a laptop. Those aren't lights. If I were to make this in something with Unity, this would just be an object that looks and acts and feels like a table. This is just an object that looks and acts and feels like a laptop. Like what I said before, we take data and we transform it every frame. And when you really think about it, it's mostly just floats in different combinations. All the triangles, all the texture data, all sorts of the state running your game, it's mostly just floats. In my opinion, premature abstraction and organization is the biggest source of friction when you need to make changes to your game. So people often throw around the phrase premature optimization is the root of all evil. I think these two are also up there as well. Maybe not as harmful, but still, they can hurt. Okay, so what alternatives do we have? Well, thankfully, Unity already has an alternative, and that's just game objects and components. Scriptable objects too, stuff like prefabs. Unity doesn't suggest dogmatic OOP right out of the box, thankfully. When you're just working through your first tutorials. Okay, this is awesome for rapid prototyping. We moved away from this overstructure and over compartmentalization of our game, but as soon as we're outside of the prototype honeymoon, it gets super messy. Because outside of game objects and components, there's no built-in suggested structure otherwise. There's often tight coupling between related components on a game object, like you have to, so each script on your object then has to get the transform and get the rigid body and know about the other scripts attached, and you have to write require component, which I hate doing that. Some other more general things, just in terms of structure. The script execution order settings also include time, which is weird. So you can specify that one script will run before and after another one, but then you include a delta time. I don't know why we need to do that. Built-in events aren't great. Send message with a sad face there. And what I've seen professionally and what I've in the AAA space and what I've seen other indie developers do is games have to fall back on object-oriented programming for bigger systems. So we have to write a bunch of singletons and managers and get our interfaces in order and all that. So what's next? I think entity component systems are next. I created EgoCS to learn more about the paradigm. There were some entity component system frameworks for Unity, but I didn't like their API, so I thought, well, I'll use this as a learning exercise and I'll keep going from there. So why I think they're the future and why I think they're so great. ECS, I'm just going to shorten it to ECS from now on because it's several syllables to say. It mandates a complete separation of state and behavior, or the data and the logic in your game. The awesome thing with this is you can change your logic of your game without invalidating your data, and you can change the data of your game without breaking your logic. So you can swap components around on different game objects, and you don't have to worry about, oh, well, am I going to cause an RE because I didn't say require component here, or all that. In my opinion, I think ECS is the necessary conclusion of Unity's built-in game object and component model. This is because it easily handles multiple coupled scripts on one game object. So the original promise of game objects and components was just, oh, throw on a script and get this behavior for free. But if you throw on multiple scripts and each of them are updating the transform or the rigid body or whatever, or each other in their own way, they start stepping on each other's toes and it gets really hairy. One awesome thing about this is you never have to write require component again. And when used correctly, you won't get null reference exceptions specifically from component references on the object, or if you're referencing components from other game objects, you won't get that as well. Right, so let's talk about EgoCS. It's a very clever acronym. It's not. Okay, so let's go through some of the let's go through some of the terminology. So there's 3 parts of ECS. The first E stands for entities. They're the exact same as game objects. They're just component containers. That's about it. Components. They're like the components that you've already seen in Unity before. However, an ECS compatible component, it's just data. And unlike traditional monobehaviors, it's only public and easily mutable data. If you'll notice here in my example, I've got a string called myString and a float called myFloat. They're both public. It's just a really plain object. I added the disallow multiple component because, just for the sake of simplicity, most ECS frameworks mandate that only one type of any given component is attached to a game object at any given time. And this, in my opinion, makes sense because for the more fundamental components from Unity, like it wouldn't make sense to have 2 transforms or 2 rigid bodies. It's in 2 places in the world at once and it has 2 masses. That'd be kind of weird. Oh, the biggest thing that I'm forgetting to mention is that it's just data, so that also means that there's no start, there's no update, there's no onEnable, there's no fixed update. The components don't update themselves. They're just data containers that get slotted into entities. Okay, so we've ripped out the start and the update from our components. Where do they go? They go into the third thing, which are called systems. Sometimes these are also called processors, depending on the framework that you're going with. I just went with the norm and called them systems. So systems only contain your game logic, the start, the update, etc. And also, you'll notice they have no state. You don't put any of your own states. So you don't put a bool is game over. You don't put game object references or component references. It's just like up here in the class declaration, there's no state. You can, of course, keep some state in the individual methods themselves, as you're processing your game objects. That's totally cool, because as soon as you leave the scope and start again, you'll get the correct and the new data. So even though I say no state, there is some behind-the-scenes caching that you guys don't see that all exists here in the ecosystem. But adding new and your own state to a system is completely verboten. Do not do it. It will bite you, and I'll be very mad. Okay, one thing about systems as well is they are completely isolating each other, minimizing side effects. So for example, let's say I have 3 systems. One's for player input, one's for player movement, and one's for player animation. So the player input will grab the controller values and then take those and put those into the relevant component. And the player movement system will take over because the player input system was done updating. So we'll move it along our pipeline. We'll get to the player movement system. And then that will grab the input data that was previously set and then move the player in whatever fashion we desire. And then finally, the player animation system will take over. And then based on how we moved it, we'll play the relevant animation. So instead of having a bunch of scripts running in any given non-deterministic order, we instead use these systems to build up a pipeline that update all of our game objects and components. Okay, so how do we do that? Some people will probably wince at this code a little bit because I'm doing some nested type type signatures here. The C# compiler isn't as capable out of the box as C++, which actually 95% of the time is a good thing because template metaprogramming is a nightmare. So what I do instead here is, so for this my example system, it's only going to, I'm mandating that it only updates game objects that have a transform, a rigid body, and a my example component. And systems are greedy. So if there's extra components attached, it will update those game objects and those components as well, but you will only get access to the transform, the rigid body, and the my example component. Now, different ECS frameworks do these in slightly different ways. Maybe you grab something from a pool, or you grab something from a matcher. I just embed it directly into the system because I really wanted the simple API. So here, in this ecosystem, each one has a constraint where on that constraint, you can then call for each game object, and then you pass in a lambda where you get the transform, the rigid body, and the my example for each game object. And then here's where you would write all the code that would update those three or work with them in whatever way you wanted. This first argument here, this ego component, that's a helper component in EgoCS that uses a bit mask behind the scenes to keep track of what components are attached to what. It's there to allow EgoCS to keep track of what's going on. Okay, and I totally forgot the size of this TV, but all I'll say here is, so how do we hook up EgoCS to Unity? All you do is you create an ego interface. So this is the most normal Unity thing that's going to be in your project. You'll have an ego interface that inherits from mono behavior. So for the mono behavior start, you'll call ego system start. Update calls update. Fixed update calls fixed update. And then up here in this constructor for the ego interface, here's where you'll add all of your systems. So here I only added my example system. But if I wanted to, in the previous example, I was saying, oh, player input, player movement, player animation. So those would go in order here. You would have player input, player movement, and player animation. And then that would be the order of systems that execute. So that's how you get this pipeline behavior. Okay. So I did say before that systems are completely isolated from each other, meaning that also whenever you update any given game object, it's also isolated from everything else. So in this example, you're just updating this transform rigid body in my example on their own without references from anything. So for example, maybe my example had a speed in it or something. So how do you actually get objects to interact, at least with collision and stuff like that? Well, most entity component systems, like their libraries, they also include some sort of event system. EgoCS is no exception. It has a type safe and user orderable event queue. So by type safe, you just pass in the type of the event that you want to raise. So here I just add a handler in this system, and then every update I'm adding an event, for this event. I'm just creating it, and then these event objects are just as simple as possible. It's like, oh well, so if a collision happened, you figure out which two things collide, put those in the object, and then you go from there. If you're working with, we'll go into some more examples of specific events later, but I just wanted to have this. It also uses an event queue. So the reason why I do this is just to minimize what I've seen called temporal coupling. So this is, if you're doing something out of order, maybe something could go wrong. So the reason why I use an event queue is so that I can grab all the events and handle them after every system is updated. So the order goes, update all your systems, handle all your events. Next frame, update all your systems, handle all your events, and so on. I'm just going through just really quick examples. There's a full wiki with this, and there's an example project that I'll show in a little bit as well. All of this is up on GitHub. Okay, and yeah. Oh, great. Speaking of, we got with EgoCS. So this is the example project that I guess I'll show off. So here, this is just the current scene that I've got. I've still got my camera. I've got a ball object and a paddle. I've got, the four walls. I've got some UI. I've got what I call a lose area, so it's this section down here with the paddle. But if you'll notice, as I'm going through all of these game objects here, they're pretty simple. Like, I've just got a ball, and on it, there's a ball component with some initial speed and initial position. And if I open that up, in my Visual Studio, there's still it's kind of small here, but there's still no methods. It's all data, because all of that data goes into these systems that I was talking about before. So let me actually open some of those up. Let's see, systems, right. Okay, so let's look at the brick system, for example. Let's see what that does. Systems, brick system. Cool. Okay, so here in my brick system, again, there's no extra state, and all we do here is we say, okay, this system is gonna handle collision exit 2D events. So I have a lot of built-in events that handle all the different types of collision and trigger events already in Unity. So I'm just gonna handle this method here. So what happens is here, so I get the event. In this specific event, I figure out, okay, well, two things collided with each other. So does the first thing have a brick, and does the second thing have a ball, Or the opposite case, does the first thing have a ball and the second thing has a brick component? So then if they do, then I pass in brick hit. So what I'm doing here is I'm figuring out, so this brick system gets every collision exit 2D event, and then all it does is it filters out if those two game objects, if it filters out the game objects that it doesn't care about. So here, if the first one, again, has a brick, so if a brick collided with a ball, or if a ball collided with a brick, then we'll call the brick hit method, and then we'll pass in the relevant components, and then we'll go from there. So let's see this thing in action. It's just a really simple breakout clone. Again, it's up on GitHub. So you see, it's a standard breakout. Ball's going around, I'm destroying bricks. But then something really cool can happen. So now that all of my game's logic is in systems, and it's not on specific game objects or specific components, where if you enable or disable them, that could have ramifications across other game objects, because, like this one needed to update in this object in this particular way, and then it indirectly passed that off to this. So now what I've got here is in my EgoCS, my root, game manager object, I've got my Ego interface here, and these are all the systems in my game right now. Not sure why 2 of them are named ball. I'll look at that later. But so let's look at some behavior in my game. So I'm going to try to purposefully lose. Oh, I did, right? Because my ball went past the paddle. So if I play again, now if I pause the game, what I can do is I'm just going to turn off my game end system, and let's see what that does. Oh, cool. So I've turned off that functionality of my game with a button press, and there's no side effects. Pretty cool. Okay, let's see what happens then if I turn off the brick system. Oh, great, they don't explode, which is actually what I want. And then, of course, I can just turn that functionality back on, and that brick got destroyed. So the awesome thing that I really like with working with entity component systems is you are turning off and turning on functionality. You're not enabling and disabling game objects and components. It's just, if I want to turn off the score updating, now it's off, and my game will run that way. Now it's back on. Now the game end system will work properly again, and hopefully, yeah, that's it. Yeah, so that's just a really simple demo project. Let's see, let's go back to the presentation. So this, I found, is the biggest win, especially when you're debugging your game. If you only want to, if you just want to diagnose a problem, you can turn off all the other functionality of your game except the stuff that you really want to worry about. So if you only really want to worry about what happens when the enemy hits the player, you can do that and turn everything else off to help you diagnose the problem better. Okay, let's go back to my presentation. Cool. Okay, so back to back to what I was talking about before, like some of my gripes with some of the tried and tested ways that we use to create games. So entity component systems versus state machines. I love how in ECS I don't have to care about transitioning between states. All I care about is the final state. So if we think about, if we're in this state in the middle here, I then have to worry about all the different transitions that I can make out, or that I can get out from that state. Then I end up in any given state. Then I have to look at all those transitions to figure out where I'm going from next. So let's say if I wanted to get up here, like if I'm in this middle state, and if I want to go to this this northwest state up here, well, I have to diagnose all of these transitions, and then all the transition that those two states are connected to, and then all of those transitions, etc. So it becomes this nightmare web. Whereas with an ECS, it just gets all the data that you have at the start of your game, and then rather than pinballing your way around a web, you start at the top and you just plinko your way down into where you want to be. So for example, let's say if I'm landing in this state, but instead I want to be over here, well, then I just go back up and figure out, there was a branch here. Why did that happen? And then you can diagnose that. The awesome thing with ECS2 is you can be in more than one explicit named state at a time. So one system can only worry about so different systems can have different definitions for when something is going on. So for example, you could define in one system that bullets go fast when their velocity is 200, but in another system, the player is going fast when their velocity is over 2 or 3 or whatever other smaller number. So the awesome thing with this is, yeah, you don't have to explicitly define what state you're in. You're just worrying about the data as it is, and then figuring out, based on that data, how to transform it. Okay, ECS versus OOP. It's basically comparing Lego toys versus die-cast models. So let's say you make a car out of Lego versus you've got like a Hot Wheels toy or a model off the shelf. So there's no question that that Hot Wheels toy is a car because it came out of the factory that way and it looks like a car, it's one solid piece, no one would debate that. Somebody looking at the Lego car could make some weird philosophical argument that, you know, oh, well, it's just a bunch of Lego parts put together and it acts like a car, but it's not really a car. But, you know, if a kid will have the same amount of fun with the Hot Wheels toy as a car versus they'll have the same amount of fun with the Lego toy as a car. So with this method, and this is just an extension of the game object and component model from Unity, we don't have to explicitly define and keep up with what something is. Like, we don't have to say that this thing in our game is the player, and this thing in our game is a chair, and this thing in our game is an enemy, etc. Because of the functionality provided by the systems and all the different ways we can combine components on game objects and components become more than the sum of their parts. And thankfully, with systems and their constraints, we only work with the components that we want to update. So it avoids premature encapsulation. If I want to update a particular object, if I want to change its position based on some speed value in a component, well, I just constrain to those two components, look into the speed component, and then put that info in, and then update the transform accordingly. So in my opinion, this avoids premature encapsulation. Again, encapsulation is a good idea, but just we've gone overboard a little bit. And I think that ECS, for certain kinds of games, especially in the super secret side project that I'm working on, I find it's the best amount of abstraction, which in my opinion is as little as possible while still being easy to work with. So, you know, to make the most performant and the best games, we should be using stuff like assembly or C or like really low-level stuff. We need to really get into the nitty-gritty. But some abstraction is necessary because we do have a job to do. We do have a deadline. We want to make things at least somewhat easy for ourselves. We want to make sure that if the design changes, we want that change to be easy. We want to make the coding experience pretty good. We don't want to pull our hair out because we're working with assembly or C or something else just silly. Okay, so while ECSs are fantastic, and I'm using them, I even made a library for one, there are some specific caveats where they're not so great. So if you have a game with an explicit sequence, like a cutscene, or maybe you have some pre-programmed tutorial sequence, ECS isn't going to be that great for that. The reason why is because ECS has no concept of history or future. It just looks at the data that it has right now and updates from there. So you, in theory, you could make a cutscene system in an ECS, but it would be a headache. Don't do it. One thing that ECSs aren't that great for is also hierarchies of game objects. Not so much inheritance hierarchies, but stuff like UI, where you have an element is inside of a list and a scroll view and all that sorts of stuff. All that sorts of stuff. However, I'm starting to work on that because EgoCS does have an ego parent constraint. So in a system, you can define what constraint any game object should have, but then on top of that, you can also define what the parent should have, and what the grandparent should have, and the great-grandparent, etc. So you can nest these parent constraints, finally end up at a child constraint, and you can work on all those game objects pretty seamlessly. I'm still working on how to make a more UI-friendly, an ECS-friendly UI, but I'm still not there yet. Complex AI is also not going to be great for ECS right out of the box because complex AI, like your agents running around in the world, they need a lot of data that they don't own. So for example, like, an enemy soldier running around will own his position because it has a transform component. It'll own what direction it's aiming its gun, but it won't necessarily own the path that it's taking, or it won't own the position of its target, or it won't own the awareness state of a target, stuff like that. So in theory, you could create a complex AI system in ECS using a lot of different events, but it wouldn't be fun, just a heads up. Also, throwing any ECS, not just EgoCS, throwing any ECS into your project and expecting immediate results is not going to be that fun. Unfortunately, it works the best as soon as you're at the start of your project. Granted, as you start integrating an ECS into your game more and more and more, I think you will reap the benefits, but there are going to be some growing pains. What else? Right. So, EgoCS, it's of course on GitHub. It's actively maintained. I've got a pretty decent documentation wiki. It's very easy to get in contact with me. There's a gitter.im channel that you can find in the README. My email is on my GitHub. You can @ me on Twitter. I do accept pull requests if you guys have some features or whatever for that. And yeah, thank you. Q&A? Any questions? Questions? Anyone? Yes.
Well, first, thanks for the presentation. Nice.
Thank you.
I have two questions regarding the order you add the systems in.
Right.
And can that make it like problems? Like you have to have a dependency on the order the systems are in order for the data to transfer properly, right?
Yes, that is one.
Can you repeat the question?
Okay, sorry. So the first question I think was the order of your systems is now also a dependency in your game. Yes, that is going to be a dependency, but I think that's a decent trade-off because in our typical game loops, we do have some order. Like we do want to generally get input, update everything based on our external input, like from a network or our game controllers, and then we want to move everyone around accordingly, and then from there, because people have moved or not, we want to then update their animations. So I think in general there is going to be some order. So it doesn't mean that every system might necessarily have to run like one after another in like one long linked list, but you're probably going to have sections of systems that you would want to run in front of each other. But that will be up to you and up to the type of game that you're making, unfortunately.
My follow-up question is, either in EgoCS or other systems, is there a way to have like a encapsulated system in the sense that that's running subsystems in there? Is it a good idea?
Okay, so the question was, in EgoCS or in other ECS frameworks, can you run subsystems?
Let's say you would say player movement runs player input and something like player animation within a subsystem, just to have it so the dependencies is not as hard. Is that a good idea? So the question still was, can you have subsystems where you can put all of your dependencies together? My argument with that would, so you wouldn't necessarily want to group all of the player systems together and the enemy systems together, because the input from your player is going to change how your player moves, but it might change how your enemy moves depending on that. So we don't want to group together related objects. We want to group related concepts in our pipeline. So like input and movement and animation and UI, just as an example. There is another, like the most full disclosure, the most popular ECS framework out there right now for Unity is called Entitas. I looked at them first. They've been around for a while, but I wanted to learn more about it and make my own thing, and I had some issues with their API, but yeah, so I wanted to make my own thing. They have that capability where you can easily group together systems and make the dependencies more explicit. But in terms of systems, you don't necessarily have to keep a strict dependency order, because given the state of your game at the start of the frame, you don't know if that dependency even makes sense. You just say, okay, here's the state of the world, run it through all my systems, it changed in some way, cool, do it again. And that's about it. It goes to what I was saying before, where in our games, all we're doing is just transforming data. And so for something like that, we don't necessarily even need to transform our data in one frame. We could, like, Unity does this with coroutines, and there's the asynchronous stuff in C#. Like, we could spread things out. That's okay. But as long as we're just changing data, I still think that's fine. Hopefully I answered your question and didn't ramble. Okay, cool. Yes?
I saw that you use some try get component.
Right.
Did you use your system on big project, and do you know the overhead or garbage collection? Is that the preference?
Okay, let me just actually find that in my code so I can, right, okay. So in terms of the garbage collection hit, you'll notice that I have from this event, the question was, what's the GC overhead when you're doing try get components and in general the system. So there is some initial overhead up front, because in order to make all of your game objects in your scene compatible with EgoCS, all of your game objects do have an Ego component on them, just to keep track of everything. And then what I do in the background is there's just a constant size bit mask that's keeping track of which components are attached. So if it's attached, it's a 1. If it's not, it's a 0. And the length of that bit mask is just how many component types there are. So when you're calling try get component, there's no overhead to that in and of that call itself, because it's just looking at a bit mask. Has components, same thing. It's just looking at the bit mask again. That's why I'm a big fan of these variadic generic. So you can do has components, and then actually let's look at that. So in has components, I have a few different types. So you can pass in 1 all the way up to 5 to check to see what's going on there. Just in terms of general overhead, and this is EgoCS specific. So I said before, every game object in your scene is going to have this Ego component attached to help EgoCS keep track of everything. What else? Oh, right. I'm working on this, but right now, at the very start of your game, I use a tiny bit of reflection to iterate over all of the types, figure out which ones are events, figure out which ones are components, and then once that's done at the very first frame, then I'm done. I never use reflection again. It's just to get all the types and set up the bit masks and all that. In terms of...
Are you caching the components?
Yes, I am. That's the other reason for the Ego component there. Oh, well, so here, when you're calling try get component, if it has them, it does call get component right there. So this should be used as liberally as, conservatively as possible. But that's why, so here, if it doesn't have any of the components attached, it won't get them. That's why it uses the bit mask, because I was under the assumption that, especially with collision, more often than not, the two things colliding are not going to have what you want on them. Was there anything else to that, or?
Did you try it on big projects?
I'm working on my own side project right now. All I'll say about it's going to be a character-driven 3D action game. So more like a character spectacle fighter, like your Devil May Cry or your Bayonetta. It's slow going on that, so I haven't used. Oh, sorry. The question was, have I used this on a bigger project? And I'm using this specifically with my side project. That's why I'm adding new features to it as I need them in my side project game. So far, it's going pretty good. I haven't noticed any bottlenecks or slowdowns. The biggest bottleneck is going to be at the start. I've actually found I've gotten more. So by following this, I've actually saved a bunch of development time, because I just write out my logic in those systems, and I don't have to worry about non-deterministic calls to update and all that. So I've saved a bunch of time that time. Full disclosure, on my side project, I also haven't done much profiling. That's because I'm still working with some of my artist friends to get the assets for me with that. But then, of course, once I get there, I'll have the profiling data for that. But I think it's going okay. I know this is being used in a couple of student projects. I forget the fellow's name, but he's doing his VR thesis project with this, and he's over in Berlin.
I know of at least there's at least a few people using this. I do want their feedback in case something's going wrong, and if any of you use it, I do want your feedback. I want to make this the best library as I can be. But if you're super worried about performance, you could also look at NTTAS. That's the other. Okay. Okay, great, cool. Anyone else? Yes.
I want to always have this question about what's the difference between an ECS and an NBC pattern. I mean, it seems to follow the same concept behind it.
I'm not too familiar with NBC because I mainly went straight into game dev with my studies. Like I didn't go through like more traditional programming. But what I've seen with MVC is its structure comes from the model updates the view like its structure is very circular, whereas an ECS is very much like a pipeline. Like all of the data for your model or your there's no blurring between model and view. It's just your components and whatever game objects they're attached to, and all of your logic is in systems. Whereas in an MVC pattern, your business logic, I guess, would go into your controller, and you would also have view logic, but there's no distinction between the two. There's just data and logic. I hope that answered. Oh yeah.
And one more question is, I tried using EgoCS. The problem I had was when I imported assets from the asset store, it was difficult to modify them to fit into this model.
Yeah,
So
it's
as I scaled it up, it became very difficult for me to follow the.
there's so.
Repeat the question, please.
Oh, sorry. So the second question was, or the second statement was, the gentleman tried to use EgoCS as well as some assets from the asset store, and it was hard to integrate the two together. The biggest downside that I've seen so far from using any ECS framework is that it assumes that it's the only thing controlling your game, like that it's the only place where any logic is happening. The good thing about the Unity's built-in GameObject Component model is that because everything can update itself, that's great for assets because you can have your path manager doing this, and you can have your builder doing this, or like all the game objects can update themselves on their own, and it's way easier to just throw a bunch of stuff in your project and get it working right out of the gate. That is going to be one of the downsides. If you grab any old thing off the asset store or GitHub, it's going to take some time to integrate it into an ECS. However, there is something that you can do. Let me just go back to my slides. So let's see. So here, when you have your update method, the Unity monobehavior update method just calls egosystems.update. So from this method call, all of your systems get updated. So if you want to do something before or after, you totally can. You can also go into the default Unity script execution order and make sure that your Ego interface script runs before or after. So that would be the biggest thing I can see to help integrate your game. So you make all of your asset store stuff run first or afterward, and then your ECS runs as its own sort of one conceptual unit like that. Any other questions? Yes.
I'd like to know about the events, and maybe I didn't understand correctly, but it seems like if you use threads, there's a possibility that you will change the state twice.
Oh, this is not thread safe at all. This is going for, when I was first creating EgoCS, it was still just following the default. Like one of the reasons why I didn't the statement or the question was something could happen if you're using threaded code. EgoCS is definitely not thread safe. Do not run this with multiple threads. What I wanted when I first wrote ECS, this library is 2 years old. Just some backstory. I wrote it when I was just out of school, puttering around, still looking for work. So it's not as full featured as NTTAS, but I'm only showing it off because I want people to rather than just use EgoCS, I want them to think about
entity component systems as a whole. So going back to the original question, no, it's not completely thread safe because I wanted something that was really easy to integrate with the default Unity workflow where you just have GameObject components and you edit those components in the inspector, and maybe you have prefabs. What NTTOS does was it essentially reinvents the whole wheel, and you create components that only work with NTTOS, and it has its own inspector and all that. So I just wanted to make the simplest possible system that I could. That yeah is definitely not thread safe. Don't try that. No guarantees of what will happen. Considering the next talk is about where multi-threading is going to Unity, I'm actually really excited about that, because then if Unity is whatever they're going to be doing next, hopefully it'll be awesome. I'm sure it'll be awesome. But whatever they're going to be doing with multi-threading gameplay stuff, we'll see, but no promises. And then you wanted to see more about the events, or?
Well, because when I worked on a project with a lot of server interaction, and you have to start a new thread and listen for server messages, right?
Oh, okay.
And then in Unity, you can't call the main thread from an old thread, or your thread doesn't allow.
Yeah.
Like that. So you have an event queue, which is exactly what we need to use for cross-thread communication. And that's why I was wondering if the event queue was for threads. But my real question here would be, right now it's not thread safe, but is it still possible, considering like our other CS systems thread safe, and could this one be in the future?
Possibly, yeah. NTTOS I know is multi-threaded, but what they do is, so because all of their components are custom, like they re-implement the transform and the rigid body and all that, what they do is, at the start of the frame, they transfer everything out of the main thread, all the data out of all the components out of the main thread into their own thread pool, I think, and then they go wild from that, and then right at the end they bring everything back in with their so they use one system at the very start to transfer or a group of systems to transfer everything out at the very start. They do their own thing on their own in their own thread pool, and then they bring everything back in. Theoretically, you could do that as well with EgoCS, but I just have an event queue just to handle the single-threaded temporal coupling that you can have in your game. But no promises, but I am interested, of course. But I just wanted to make the most simple, concise framework as I could.